Earth may have had a ring system 466 million years ago during the Ordovician period, according to a recent study. This idea stems from the discovery that 21 asteroid impact craters from that time are concentrated near the equator, despite most of Earth's continental crust being outside this region. The researchers suggest this unusual pattern resulted from a large asteroid breaking apart after a close encounter with Earth. The asteroid fragments formed a debris ring around the planet, similar to those seen around Saturn. Over millions of years, debris from this ring gradually fell to Earth, causing a spike in meteorite impacts, known as the Ordovician impact spike. This hypothesis is supported by the presence of high amounts of meteorite debris in sedimentary rocks from this period. The potential existence of a ring system could also explain a significant global cooling event, the Hernantian Ice House, which occurred near the end of the Ordovician. The researchers speculate that the ring might have cast a shadow on Earth, blocking sunlight and contributing to this dramatic climate change, making it one of the coldest periods in the last 500 million years. This finding challenges traditional views of Earth's history and suggests that extraterrestrial events like asteroid encounters could have had a significant impact on the planet's climate and life. The team used geographic information system analysis to identify regions where craters from this period could have been preserved, focusing on stable landmasses with rocks older than the mid-Ordovician. Space travel can weaken your heart tissues, according to a recent study. This adds to the list of adverse health effects associated with prolonged exposure to microgravity. Conducted by researchers at Johns Hopkins University with support from NASA's Johnson Space Center, the experiment involved sending 48 samples of bioengineered human heart tissue to the International Space Station for 30 days. The results showed that these tissues lost strength and struggled to maintain normal rhythmic contractions, revealing the cardiovascular challenges astronauts face during extended missions. Previous research has documented that astronauts experience muscle atrophy, bone density loss, and other health issues upon returning from space. But this study focused on the cellular and molecular impacts on heart tissue, using human-induced pluripotent stem cells to create heart muscle cells and placing them in miniaturized tissue chips. The researchers were able to simulate the heart's environment and monitor contractions in real time. The findings revealed that in microgravity, the heart cells exhibited weakened contraction ability, arrhythmias, and structural changes such as disorganized protein bundles and altered mitochondria. These symptoms are similar to those seen in age-related heart disease and suggest that microgravity accelerates cellular aging. The research team plans to conduct further experiments, including drug tests to protect heart muscles and studies on space radiation effects to develop strategies for safeguarding cardiovascular health during long-duration space missions.
Scientists discovered the largest known galaxy ever, named Alcyonius, which spans over 16 million light-years in width. That's 160 times wider than the Milky Way. The newly discovered galaxy resides 3 billion light-years away. The team detected the galaxy by observing the two jet streams emitted by a supermassive black hole typically found at the center of many galaxies. Alcyonius houses a supermassive black hole at its core, emitting two massive plasma plumes that contain the building blocks for new star formation. These plumes, stretching more than 100 Milky Ways in diameter, represent the largest known galactic structure. Despite the relatively normal features of Alcyonius compared to other radio galaxies, astronomers are still puzzled about its enormous size. Initially, scientists speculated about factors like an exceedingly massive black hole, an extensive stellar population, or extraordinarily potent jet streams. Alcyonius appears to be below average in all these aspects compared to its smaller counterparts. The team plans to investigate whether the unique characteristics of the radio galaxy's environment could help explain why these giants grow to such enormous sizes. Alcyonius Galaxy derives its name from the son of Uranos, the Greek primordial god of the sky, and is an ancient Greek giant who famously clashed with the hero Hercules and other mythological figures in their quest for cosmic dominance.